Oh, today was a stressful morning for me. Getting kid to school did not go like it usually did. How are you doing, Josh?
I am doing not enough sleep as usual, but we're here and I'm happy and I'm excited.
Yeah, day 13. We're
Yes.
almost halfway now. Or wait, does that
This is
finish
past halfway,
it?
right?
Yeah. It finishes at 25th, right? Yeah. Okay.
Oh, does it? I thought I finished at the 24th.
Oh, 24th, maybe it does.
Yeah, double checking. No, 25.
No,
You're
25.
right.
Yeah.
Hey.
Alright, anyway, let's have a look at the puzzle. Transparent origami. You reach another volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. When you activate it, you're greeted with congratulations on your purchase. This is going to be a common theme for today, just me making silly mistakes. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual. Apparently, the elves have never used this feature. To your surprise, you manage to find the manual. As you go to open it, page 1 falls out. It's a large sheet of transparent paper. Let's look at transparent paper.
Yay.
Transparency. Projection. Oh, like it's got overhead projector. I remember overhead projectors. Transparent paper is marked with random dots and includes instructions on how to fold it up. So we've got a bunch of dots and a couple of folds. First section is a list of dots on the transparent paper. 0, 0 is top left. Okay, makes sense. So this is what the graph looks like. There's a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper up for horizontal lines and left for vertical lines. Okay. Makes sense. Because this is a horizontal line. Okay, so this folds up and it makes this shape. And any overlapping dots just shot as one dot. A vimfurl. And then it makes a little square. Nice. Okay, the transparent paper is pretty big, so for now, focus on just completing the first fold. How big are we talking? Big. Oh, Jesus. Okay. Yeah, really big. Alright.
Yes.
Okay. So, we're gonna essentially for each fold calculate the new positions of any dots to the left or below the line and translate them into the new space.
Yeah, I believe it's like you flip both axes and then you merge the grids somehow.
I mean, you could do that. Yeah.
What are you thinking?
I'm just thinking of having a set for the points and translating the coordinates.
Oh, I see. all right, yeah, that'll do it.
I mean, either way will work, I think. But yeah.
Fair enough.
Okay. Ready?
Yes. Good luck. See you in a sec.
Okay. Let's get started. Alright, so I will paste in the test input because I always forget to do that. Alright, and now I have to think about how to parse this. So I think we could do lines is TL views get lines of our input, and I'll shove this in a vector. Gonna need TL get lines, gonna need TL2, gonna need vector. Okay. Also get ranges. Okay, so that will be our lines, and then when I just find the empty line, empty it equals std ranges find for lines are empty string. Okay, and then for each line in our subrange from lines dot begin up until empty it this will be our coordinates. So I'll have a std. I'll just do a normal set of points, which I'll just call graph. Gonna need include set. Gonna need a point type, which will just be x, y, and a default comparison operator. Default, okay. So we loop over all of these and we do graph dot insert. We're going to split them. I have a split implementation in here. Thanks to follow hunting swan. So we're going to split, two integers, our line. Then we're going to insert S0, S1. Oops. Stick this in braces. Fix formatting. Okay. So this should have our this should represent our graph now. And now we want to do our folds. So for, well, we only want to do the first fold for part one. So that's going to be fold is std ranges next, empty it, skip over the empty line, get the next one, and let's use the CTRE, compile time, regular expressions, copy paste the syntax because I always forget it, include CTRE, and what format is this in? Fold along the axis and the coordinate. Fold along dot equals dot plus. Was there a space in there? No. Okay. All right. So axis. Actually, we can do this. Axis. Coordinate. Okay. So now we've got our axis. We want to loop through all of the points for each point in our graph. If the axis is x, then we want to fold left to right. So if p dot x is less than x, then we're going to graph dot remove our point. We're going to wait, is it remove the right name? I can never remember. Set. This is advent of code. We're doing essentially graph transformations where we've got this sheet of paper with dots on it, and we're going to be folding it, translating these coordinates. Hey, the Nick person. So remove, delete, erase. That's it. Graph to erase p. Can this take a value type, not just an iterator? Yes, it can. Okay. We erase p, and then we graph dot insert a new point, which will have the same y coordinate, but its x coordinate will be, let's see, what's the maths here? So if we want to translate this position to here, it will be the coordinate plus the coordinate minus the original x. I need to make this chord will be some compile time regular expression match type. I need to convert it to an int, which I think is chord.stir. In fact, I'll do this the other way around. What did I say this was? Chord plus chord minus p dot x. And this is chord. This is p dot y. Okay. And if the axis is y, then if p dot y is greater than chord, because we're doing from bottom up, then we erase the point and we do p dot x, and the math should be the other way around for this one because we're doing bottom up. Will be coordinate minus y minus coordinate. Chord minus p dot y minus chord. That the correct maths? As anyone who has been on the stream before will know, I can never do basic maths on stream. It always fails. Anyway, let's give this a run, see what happens. Okay. Failed to build. Split. No matching overload found. I split it on comma. Line undeclared identifier, line 28. 28 says fold. Hey Rashad. Yeah, we're doing pretty well. Day started off kind of sucky, but we're getting there. Had a bit of a rough morning. Okay, it built, it ran, and we got a out of bounds error for P in, well, we're looping over the graph. Oh, because we're erasing from our set while we're iterating through it. Let's do this with iterators instead. Auto it equals graph dot begin. For, you know, I can stick this in here. It is not equal to graph dot end plus plus it, and then when we do an erase, we give it the iterator, and this gives us back a new iterator, I believe. Yes. And same here. P equals dereferencing iterator. Try this. Oh, got another debug assertion failed. Thanks for the follow, Leon and Neil. What's going on here? I'm still getting out bounds for our graph. Why? Anyway, let's check our graph first. Our graph looks, well, that looks very, very wrong. Oh, it's the, you have to do like the erase, if you want to erase an element from a stitch set. Can you just do this? This just work? It should, right? Let's stick a breakpoint at the start here, see where we're going wrong. Maybe I just have some bad parsing. Okay, so our fold along y equals 7, that looks correct. Our axis is y equals 7, that's wrong. Oh, well, maybe that's just how it's represented internally. Anyway, our coordinate 7, that's correct. Oh, should I maybe do, let's do this. Do axis match, coordinate match. Axis equals axis match dot stir. Just convert it to string from the internal representation just to make sure that we're all good. We should double check our graph as well, make sure it's got all our points. Okay, our axis is y, that's correct. Our coordinate is 7, that's correct. Our graph is 18 points, and looks like that. What was that? 0, 3, 0, 13, 0, 14. 0, 3, 0, 14, 0, 13 looks reasonable. 18 points, 1, 2, 3, 4, 10, 11, 12, 13, 14, 15, 16, 17, 18. Perfect. Okay, so our parse looks okay. So we're just doing something wrong in our implementation here. So if the axis is x, which it's not, it's y, then if p is greater than chord, so our point currently is 0, 3, so this should fail. So we just continue going until, okay, so we just did, we're about to do a graph.erase. Am I doing something wrong with this set erase function? AHAZC. Let's see. So the first one doesn't change anything. The second point should fold because it's 13. So we do, we first erase it from, this is a dangling reference. After we do the erase, we need to do a copy. Let's try that again. Okay, so the first one we don't fold, the second one we do fold. So we erase from the graph and then we do an insert. Which looks a lot better to me. But we still get debug, assertion failed. Should be p.x is greater than chord. No, because we fold from left to right, right? Where are we? Fold instructions. Yeah, you fold the paper left. Oh, right. Yeah, you're right. You're right. Yeah. God damn it. Okay. So this is going to be the same maths here as well. Chord minus p dot x minus chord. Like I said, we're going to be failing basic maths here. Okay, let's try that. I mean, that shouldn't change our looping logic, though. There's still something wrong in the looping logic. You should be able to loop over the graph while changing it because I assign the iterator to erase, I think, or maybe not actually. Yeah. Because the return value, the iterator following the last removed element. I guess it's not allowed in set. Can we change the elements? Or they? I thought surely the set elements are. are non-mutable because you'd have to reconstruct. You'd have to push it back into the set. So iterator type. Maybe we can. Let's just try it and see what happens.
Hey, we got the first one.
Nice. We're just screwing up our set iteration logic a little bit. Do you want to read the second part while I try and fix this?
For sure. Oh, whoa! It's just one paragraph.
Is it literally just?
So it says, part 2. Finish folding the transparent paper according to the instructions. The manual says the code is always 8 capital letters. What code do you use to activate the infrared thermal imaging camera system? What?
Oh, do we need to print out the results?
Oh my god. Yeah, probably. Wait. Oh, yeah. I think if we print it rather than like programmatically try and like infer it, it'll probably be better.
Mm-hmm.
Okay, so that's annoying, but okay.
Alright. See you later.
Good luck.
Okay. So this is const, it seems. We can't modify this. Yeah, it's pretty much an origami simulator, Geeky Marcat. So what's the best way to do this then? If I can't, I guess I can just collect a vector of elements to erase afterwards. Yeah, I could do 2 sets and then I could just replace the first one with the second one. New graph equals graph. Okay, so we can just get rid of that stuff there. Point in graph. If the axis is x, then if p is greater than chord, then we're gonna do new graph dot insert this and p dot y. Otherwise, we're gonna do new graph dot insert just the point itself, and then we're gonna do very much the same thing for y-axis. X. Okay, so that should accumulate everything into a new graph, and then we can that should be our graph after a single step, so we can do cout new graph dot size. Let's try that. Even for okay, 27, is that correct? 17 dots are visible, that's not correct. What's going on? Anyone seeing my mistake? So we've done a single fold. Checked our new graph. Let's set breakpoint here, see how a new graph compares to the old graph. Okay, so the size of new graph should not be larger than the size of our old graph. Oh, Jesus, I shouldn't initialize this to... Yeah, there we go. I just need the type. Can't remember what type it is, let's just do that. It's just a set of points, but whatever. Okay. Is that 17? Yeah, 17. Okay, that's better. Yeah. Okay, let's get our input. Seven, 2, 4. Yay. Okay, part 2. All right. So you finish folding the paper and then print it out. Okay. So let's make this into a loop for fold in ranges sub-range from the point after our empty iterator to the end of our lines. Okay, that should give us all our folds. We then do all of this, and at the end of this loop we assign graph is new graph. Some formatting has got screwed up here. I think it might just be confused by this fold expression, or am I missing a... Yes, I'm missing a parenthesis here. It's better. Okay. So that should be our folded graph. And then we can just... We need to print out our graph. So we can do something like... I guess we need to find the max x and y. So max x equals std ranges max element from our graph, where our predicate is std ranges less, and our projection is auto, or I can pass a member function pointer here, I think, point x. And here max y is the same but y. Okay, and then I can just let's just do a vector of vectors and initialize all of these to dots, and then we'll fill in a vector and then we'll print it out. Vector of vectors of bools. Vector of bool, we're going to be evil. Dot graph, which is going to be whoops, graph dot resize max x, and then for auto line in dot graph resize max y, and then for each point in our final graph, dot graph point.x, point.y equals true, and then for each line in dot graph for each bool is dot in line. If there is a dot, then std cout a hash. Otherwise, std cout in fact, you know, I'll do this like this. Std cout. If there is a dot, then a hash. Otherwise, dot. It's kind of confusing that dots are represented by hashes and not dots. But, resize to y for. Yes, you're probably right. Thank you. Is that right? I don't know. I'll try it like this and then we'll see if it goes wrong. And then at the end of each line, I put a new line. Let's try that. Oh, std range is less. I need to construct. What's going on here? Cannot convert from. What's going on? Line 58. Resize. Oh, this is a iterator. Still line 58. Cannot convert from const point up. Max x arrow y. Arrow x even, because this just gives us back an iterator into our points. Okay. Debug assertion failed. I guess this is what you're saying, Sylphian, that I'm just indexing my vector incorrectly. So you're saying I want to do this and then, is that correct? Debug assertion. Yeah, using a 1D vector and feeding offsets might serve me better. So resize with y. Then I resize all those lines with the x. Our dot graph is of size 538. Resize +1. Yes. Thank you. Because the max element is 0 indexed. Yeah, I could do a membership test each. Oh, we got it. Nice. CPJB ERUL. CP. CP JB CPJB ERUL ERUL ERUL. Submit. Amazing. That was a cool little puzzle. I like that. Let's tell Josh we're done. Hey Josh, we're done.
Oh my god, you gave me a heart attack. Hey, cool. All right. I am almost done. I'm doing the printing stuff in a way that is like probably too roundabout, but I'm having fun with it.
Yeah.
Shall I share my what's it called? My thingy? My thingy thing?
Yep.
The live share? Okay, great. Okay, creating a linky. Yeah, I found opportunity to use the unstable group by.
Unstable
Slice group by. Hell yeah. As in, it is still on unstable.
Oh, okay. I was like, is that doing like an unstable partial sort or?
No. The word unstable means multiple things, I guess.
Yeah. Darn overloaded terms.
Most definitely.
You pasting in the live share link? Oh yeah, just got it. Okay.
Yep.
Let's join Yosh. Live share. Join. 1 sec.
I'm patting a cat in the meantime.
Okay. And we're with you.
Yay. Okay. Cool. So we're on line 32 here.
Mm-hmm.
And we are doing the unstable fold.
Okay, so
Fold bit.
wait, have you done all the folds yet, or are you just doing this?
Have I done all the folds yet? Yeah. Like I'm all done with that.
Oh, okay. So but that says just the first fold.
Oh, just for sorry, I miscopied there. So we have our set of completed folds. Like we know that much. Like the whole thing folds correctly. That's not really an issue. Actually, I just made that statement, but let me verify.
So do you do the same kind of thing that I just had a set, and then for my folds I just created a new set, and then yeah, you did something very similar to me.
Yeah, I just inserted everything in the set, and then I looped over it, and if a coordinate was past the fold, we just changed it.
Yeah.
And create a new set out of it.
Cool.
That seems to work.
So what are you going to do for your printing? I just created a vector of the remaining elements, and then printed the vector.
Yes. That is exactly what I'm trying to do and failing at. And that was when I was like, well, you gotta create a vector, and I don't know like the size up front per se. We could figure it out, but I didn't want to.
I calculated the max x, max y, and then initialized the vector.
Okay, fine. Fine. I think that's smart enough.
People in chat are just saying that you could as well just do a membership test on every coordinate, which if it's a set, it's probably reasonable enough.
What do you mean by membership test?
So just do so I created a vector and filled it in, but you could just calculate the max x, calculate the max y, loop over the range from 0 to max y and 0 to max x, and then on each coordinate test if that point is in the set, and if it is, then output a hash. Otherwise, output a dot.
Oh, yeah, that's actually clever. I like that. That's nice. I feel sad. I really want to use group by. Hold on. Maybe we can still use group. Nah, we can't use group by. No, alas, sadly. Okay, no group by today. We'll do that. Let's calculate max x, max y, and then do the membership test and print the thing and feel pleased with ourselves because we've we've done it the right way. All right. So we have our set. We don't need to do our set. We just need to find like let max x equals set dot iter dot map, and then we have our x, y. No, is it? No, like that. X and then max, I believe. Then we do something similar here, but we take that. No, we take that. We take that. I think that's it. Yep.
Mm-hmm.
For 0 max y. Y in. For x in 0 max x. If set dot contains xy. Print line, or sorry, not print line.
Print hash.
Print, yeah, hash. Else print dot, and then here we know at the end of like every y we do another print line like that.
Yeah. You need a inclusive. Oh
yeah,
iteration.
we do, and we need to unwrap here.
Yeah. Thanks, Trissy Girl, for pointing out the inclusive.
Hell yeah. Does that work? No. Expected integer found. Okay,
Yeah, so found in my chat saying ideally you could just like iterate over the set and move the console cursor around to print at the right position. That's a nice solution.
It's nice, and I know something that if you mess that up, you'll be spending so much time. I really don't want to.
There's I'm getting weird noises. I can't tell if it's from you or if there's a cat in the corner of my room doing something weird.
Okay, I'm muting myself so you can.
Maybe it's you.
I was the cat all along. Okay.
Oh, Che _ZC in my chat saying using full block character makes the letters really easy to read.
Wait, a full block?
Instead of the hash. But you can see how it comes out.
Yeah. All right, let's run the test-through. Run test. Okay. Hey, that worked.
Did you get a square?
Sweet. Yes, I got a perfect square.
I see your square.
I'm gonna remove the to-do so we stop panicking.
Love to panic.
Panic all day, panic all night. Never stop panicking. Let's try this again. Okay, that's cool. Let's run this on a decently sized terminal.
Oh, I see it.
Oh. PZFJA. Okay, we're doing the Unicode thing. Unicode full block. I think that is a lovely suggestion. Full block. How do I copy this? I can copy it there. We're not going to print out a dot. We're going to print out a space. I think that might help as well.
Yeah.
Where's the printing? Okay, hold on. Hold on. I know how to copy and paste. I swear.
Oh, I wonder if this Unicode's going to display in my terminal built into Visual Studio over live share properly. This will be a test. Oh, it did. Amazing.
Oh, amazing. Yeah, that like full block suggestion, really good.
Yeah.
Okay. PZF. Oh, I want to copy and paste it, but of course,
How about
course
if you,
that
if
won't
you
work.
if you open up the thing, I'll read it out to you.
All right.
Right. PZFJHRFZ.
Sick. Okay, submit. Hey, we got it. Fantastic. And pretty quickly as well.
Yeah, this is a good one. I like this puzzle. I like the ones which are like they create something that you have to like look at in order to work out the answer. I remember there was one which was like you had to search through a bunch of output or something. Was it last year or maybe like 3 years ago or something? There was one where like your program outputs so much stuff that you basically like you could do some statistical analysis on it or something to work out like which bit had the most density, or you could just like watch the output and wait until you saw the correct part to look for. It was pretty cool. I liked it a lot.
Amazing. All right.
Well, thanks everyone for joining, and we will see you tomorrow. I might not be able to stream on Wednesday and Thursday as I've got some stuff on, but I will let you know.
All right. Sounds good.
All right. See y'all.
Cool.